All right, we're going to work with our converse first. Now, from yesterday, we said that if the animal is a cat, which is our hypothesis P, then the animal is a lion. It's our conclusion Q. So if P, then Q. Now, we're going to be taking that and we're going to be changing it a little bit. So if we look at the converse, which is Q, then P, what do you think happens? Guys, go ahead and put your phones away. The next one I see is mine. There's your class warning. It flips it, right. So I'm going to put it under somewhere on that page. You're going to put, we switch the hypothesis and conclusion. Okay, so we're not doing anything else but switching the hypothesis and conclusion. Now, we're not going to change anything. We're just going to change the way that it says. So, if the animal is what? A lion. Then the animal a cat. Sorry. So if the animal is a lion, thank you. Appreciate you. My math teachers, yeah. Then the animal is a cat. Sorry, guys. Struggle. All right, struggle is real. Now, tell me something. Is this true or is it false?
True in this statement.
It's true. If the animal is a lion, then the animal is a cat because all lions are cats. Yeah? Huh? Yep. So, with that said, we have our Q and then our P. All we're doing is we are switching them and restating them in a different way. Now, one thing that you have to remember is that we are not making this a new hypothesis. Okay? We're taking the original hypothesis and conclusion, just switching them. But we're not, when we move on to our inverse, we're not changing them at all. Okay? All right, so let's go on to our inverse. Let's go ahead and flip it up. So you have inverse. Now notice it has these squiggly things.
Yeah.
What do you think those squiggly things are? Not. Okay, hopefully you saw it from the other one. Yes, these mean not. When we take the inverse of something, especially in math, what are we doing? I'm sorry. Huh? We're negating it. Yes. So I'm going to go ahead and write our negation. When we negate something, we take the opposite. Okay, that's our negation. We take the opposite. So these both mean not. I know my paper looked a little bit different than yours, but it's okay. Just do your best. Okay. So, did we change our P and our Q? No, we didn't. We left them the same. The only thing that we're doing is we're going to change this and put it with a not. So, if the animal is not a cat. Oh, can't spell today. I'm sorry. If the animal is not a cat, then what? Then the animal is not a lion.
False.
If the animal is not a cat, then the animal is not a lion. It's true. Because if it's not a cat, then it can't be a line because all lines are cats. That's true. Okay, we have our contrapositive. Not Q, then not P. What do you think, guys?
Yeah, if the animal is not a line, then it's not a...
All right, so what we're going to do is we are going to switch the hypothesis and conclusion. Then negate both. So a contrapositive is just a collection of the converse and the inverse. So we're going to switch the hypothesis and conclusion, and then we're going to negate both. So if the animal is not a lion, then the animal is not a cat. What do you guys think, true or false?
False.
Okay, so if it's false, what would be a counter example?
Like Hikita is kitten.
Yeah, it's false. And our original example was a kitten. Now I'm going to add an extension to this, meaning I'm going to add one statement that you need to constantly remind yourself of. With a contrapositive, it always has the same truth value as the original conditional. So the contrapositive will always have the same truth value as the conditional. So if the conditional is false, then the contrapositive will be false. If the conditional is true, then the contrapositive will be true. Always. We're going to be moving on to writing some conditionals. Huh? Oh, biconditionals. Yes, I'm sorry. Yes, we've got to do some biconditionals. Flip it over. Sorry, I forgot about those. All right, biconditionals is our if and only if. So, bicondition. Can't spell today. Wow, that's really sad. All right, so here's what's going to be true. The hypothesis and conclusion are both true. So, P, if and only if Q. So P, if and only if Q. So what that means is, I'll give you an example. So just listen to this, okay? You don't need your calculator. So if I don't charge my iPod, then my iPod battery will be dead. If my iPod battery is dead, then I didn't charge my iPod. Okay, so that's a situation where it's a biconditional. So the first statement's always true, and the second one is also true. Okay, so we're going to write that. Okay, as an example. If I don't charge my iPod, then my battery will be dead. If my battery is dead, then I didn't charge. Oh gosh. My iPod. So the first one is true if and only if the second one is true. Biconditional. Okay? All right, so we're going to go to writing conditionals. I know, it's dreadfully boring. It's okay. Writing conditionals, you first need a statement. So, with that, I'm going to pull this picture up on my screen. And I want you to tell me. Read that screen. And give me a statement. What do you know, after looking at this, what do you know about Starbucks? That their coffee's perfect. Do you think that's true?
No.
Some people do. Man, their coconut lattes. Coconut milk lattes, yeah, they're pretty good.
That's the only thing I like to do is like
Okay, so sometimes when you make statements, they're not always going to be true because they might be opinionated. But when we create a statement, we want to look at every possibility. So let's create this statement, and I'll say Starbucks coffee is perfect. Starbucks coffee is perfect. So what's our subject?
Coffee.
Okay, so specifically, so we don't have to write all of it, I'm just going to say coffee. Now we want to create an if-then statement. So if the coffee is Starbucks, what can we say about that coffee? Perfect. Then the coffee is perfect. So what you want to remember when you're writing statements is you want to make sure that you have a subject and that you're not changing the ad. You're not changing what it's trying to say. That ad was talking about how the coffee is perfect, okay? And if it's not, we'll make you another one. So when you start creating an if-then statement, you have to say, okay, well, the coffee, if it's Starbucks, then the coffee is perfect. Just like if you use Pantene, then your hair will be beautiful. Okay? So that's what happens when you write conditionals. You don't want to change what it's trying to say. Okay, now some people are asking, why are we doing this, Ms. Hastings? This is dreadful. Okay, well, in order for you guys to really understand our postulates when we start proving things, you've got to understand this process. So I'm going to give you a mathematical example so you can flip open the math part where it says examples. So flip open examples. And I'm going to give you a math example. Here's your statement. A square is a rectangle. A square is a rectangle. So what is a square? I know it's a rectangle.
Four sides are like all the same.
Okay, so four sides are the same, right angles, all that stuff, but what specifically is it?
A shape.
It's a shape. Yeah, don't think too hard. It's a shape. So what can we say about the shape?
Four sides. The shape is rectangle.
Okay, so if the shape is a rectangle, yeah, it has four sides. But I don't want to change my statement. So if the shape is a square, yeah, then the shape is a rectangle. Okay, so what is our hypothesis here? Right. Our hypothesis is the shape is a square. What's our conclusion?
The shape is a rectangle.
Yeah, our shape is a rectangle. So what we're going to do with this example, so that you have something to take with you, is we're going to take this conditional and we're going to go through each form. So we're going to go through converse, inverse, and contrapositive. Now if you look back at our converse says if P, then Q. So how would the converse look with this?
If the shape is a rectangle, then the shape is a square.
Perfect. So we're going to switch it and say if the shape is a rectangle, then the shape